Well, in this lecture, I will introduce the Snort IDPS. Snort is a very popular and open source intrusion detection and prevention system. So today in this lecture, I will present the introduction to the Snort and what is the specialty of the Snort, what it can do. Then we'll see the installation of Snort on various platforms. So the symbol of Snort is like this. The pig will be there. It is going to sniff something whenever before it is going to eat. So this is what snort means. So actually, what is the correlation between this snort, this pig, and the sniffing? So actually, this is the meaning that the pig is a sharp sniffer. That is what the meaning of this. So in the same way, here the tool, the snort, is able to sniff the network over the network interfaces in a very sharp manner. That is what the intention of this snort tool is. So Snort is not a recent tool, but however, it has been using by the public and the researchers, academia from almost from the past 20-25 years. So based upon the network advancements, based upon the technology developments, the Snort has been modified and improved to reach the best possible sniffing and at the same time best possible way of writing the rules so that it can accurately detect the intrusions. And one more thing is the snort is a network level intrusion detection system, and it will work based on the signatures. Signatures in the sense the rules, that the rules that you frame, based on that the intrusion detection activity will happen. So let we'll see in this video or lecture that the what is in the background, what is the snort of what is in the snort, and what its features and its architecture. So basically, the successful intrusion detection depends upon the policy and management as much as technology. So security policy, defining what is acceptable and what is not being defined, is the first step in this activity. So that is especially in the policy design. Then finally, we are supposed to identify what is the wrong traffic. Then we need to give the notification that who and how fast we are going to detect this malicious traffic, and the response coordination. These three are required actually. And for this, as a security engineer, you must have knowledge of the packet structure, traffic flow, and its related information. Then only you can easily write the rules for the required security attacks. So base not is a signature based intrusion detection, network based signature based and network based intrusion detection system, and it can do the following activities. It can sniff, it can log the packets, it can use it for the forensic data analysis, and it can be used for the network intrusion detection system. So these are the four different things that you can do. For example, if you don't have a Wireshark, so you want to sniff and record the packets, you can use Snort. Okay, and as we have seen in the previous videos that how to use Wireshark for analyzing the malicious traffic. So such malicious traffic is available if you want to analyze for the wrong things in the particular traffic. Especially it will be happened in the forensic analysis. That also you can do with the Snort, and it can also be used as a network intrusion detection system. So these are the peculiarities of this Snort tool. And where did it come from? It developed out of evolving need of performing the network traffic analysis on the both real and forensic post processing. So for that purpose, it was developed around 20-25 years back. Then slowly it was evolved as a powerful network intrusion detection system. And the why we are going to choose this Snort in our course? It is very small. It is of around 4 MB and less than 4 MB itself, and it is very portable and is very fast. So that means high probability of detection of giving attack on even 100 Mbps networks also. But if it crosses gigabits, some 10 gigabits or something, then Snort may not perform that much as that much fast. But it can be very good on the 100 Mbps level uh, traffic, and it can be very easily configurable, easy rule formation, and the syntax is also very easily remembered, and reporting logging options are also available. So because of these options, this Snort has been used and preferred. And ultimately, and very important thing for any the freelancers or the startups is they require a free software, and this Snort is a free software. So Snort design is with the packet sniffing. So it is a very lightweight network intrusion detection system. So it will work with the help of libpcap. Okay, that is the library packet capture. Uh, it is required for sniffing the things. That means pcap, a libpcap or winpcap. These kind of things are required for Snort to work. And a rule-based detection engine will be there. So based upon the rules that you form, the detection will happen. And you can also plug in the system allows the endless flexibility. This can be plugged with other scripts and all, so that you can easily analyze the traffic. So this kind of plugging is also available in the Snort. And for this, you are supposed to write the plugin rules, and you need to use that plugin module for using with this Snort intrusion detection system. So because of these flexibilities, Snort is a very powerful design and can be used for the research purpose. Rules from the signature rules form signature. So what is signature based intrusion detection system that we have theoretically seen in the previous lectures? Modular detection elements are combined from these signatures. Wide range of detection capabilities like stealth scan. Stealth scan is nothing but which will scan the operating system to not to record a log. Such scans can also be detected by this Snort. OS fingerprinting, buffer overflows, backdoors, common gateway interface exploits, and other related things. So that means any kind of code scanning and information gathering related things can also be easily detected by the Snort NIDS. Rule system is very flexible, and creation of new rules is very relatively simple. And in this, three categories of plugins will be available. Pre-processors, packets are examined, manipulated before being handled to the detection engine, which are called pre-processors. That means uh, whenever the traffic is reaching the detection engine, just before the reaching to the detection engine itself, you can be in a position to identify that the traffic is malicious or correct. So this is pre-processor. Next is detection. Perform simple test on the single aspect field of packets. Then it will inspect the bits in that particular packet, and if the bits are according to the correct order of the arrival, then it will say okay, it's fine. Otherwise, it will detect um, some wrongness in the at the bit level also. Then output is in, the whatever the things identified in the pre-processing detection will be reported, and results from other plugins will also be reported in the output. So these are the three main modules for the plugins in the Snort IDPS. Three main operational modes: sniffer mode, packet logger mode, NIDS mode, and data analysis mode, especially forensic data analysis mode. So sniffer mode, packet logger mode is very simple, just like how you use TCP dump or Wireshark or WinPcap, these kind of things. In the same way, we'll use this Snort. Operational modes are configured via command line switches. That means we will place the options. If you want to only sniff -v kind of option will be used. If you want to sniff the application level data, then -d kind of switch will be used. Here, switches is nothing but the options that you will use along with this Snort command. So Snort automatically tries to go into the network intrusion detection system mode if no command line switches are given. Looks for snort.conf configuration file where you will write the configuration script, what to detect and what not to detect, and what to let to go. These kind of things will be available in the snort.conf. And using the Snort in the sniffer mode, it works much like a TCP dump, just now as I told you. decodes packets and dumps them in the std out. So by default, it will be showing you on the standard output that what packet is coming and what is the impact of that packet, what is the impact of the packet, and whether the packet matches the pattern that you have mentioned in the rule or not will be displayed onto the standard output, that is on your console. BPF filtering interface available to shape displayed network traffic. BPF means Backley packet filter. Interface is available to shape the display traffic. That means you can only filter what traffic is required, whether you want only flags or whether you want only the packet header information or whether you want only the packet size and protocol type. So you can filter it. And one more thing is basically the Snort is a command line interface network intrusion detection system. It don't have the graphical user interface by default. So it will come only with the command line interface. However, many people have developed the GUI for working with this Snort. I will discuss it afterwards. So what to do the packet dumps look like? Like if the packet dumps will be like how we have seen the win dump kind of option in the previous lectures. In the same way the option will be there. Here first it will show you the date, time, at what time the packet was sniffed, from which IP address and from which port number, the to which IP address and to which port number the request is coming, and with what type of TTL and the TOS and ID, this kind of information, okay, whatever information available with the packet request will be shown onto the screen like this. So this is the way of showing the things on the screen. So multi-mode packet logging option available. That means simple in the ASCII form. You can use TCP dump form. You can also use XML form, database form, and many other forms are available. But whenever you use database form, then you can set the configuration script to the database form, and to store this, you may use the MySQL database, so that the MySQL default tables will be created for the Snort intrusion detection system. That means Snort is having a default table settings, so that may be configured in the database, and you may link it to the database via the Snort configuration, and then you can run it so that whatever the packets are captured, it will be saved in the database, and the processing will be done with the help of database. Where in case of XML, whatever the captures will be there, it will be logged via XML form and TCP dump and simple flat ASCII. So here what I am showing here is the flat ASCII form that is directly showing onto the screen. Log all data and post process to look for anomalous activity that will be done by this tool. The NIDS mode is a wide variety of rules available for the signature engine. So many signatures are available and developed so far. See, as of now, we have so many rules, like the default rules are available, community rules are available, and many rules are available. So you can use any one of these rules. So multiple detection modes available via rules like rule signature, statistical anomaly, and protocol verification. That means it will give you the statistical information of the network capture, how many ICMP packets received, how many TCP packets received, how many UDP packets received. So all kind of statistical information will be provided. And protocol verification, whether you want to receive only ICMP, then it will check for whether only ICMP packet received or not, or protocol is received or not. So the Snort rule will look like this. Snort rules are extremely flexible and are easy to modify, unlike unlike many commercial NIDS. Simple rule to detect sub7 Trojan. So here alert TCP external net. So this is the variable name that you will write. The external net you may provide a range of the external network. That means it may not be like private networks like 10 series or 172 series or 198 series like that. So So external network, you can define it, and the port number from where the port the request is receiving, and home network. You can define a home network on 172 series or 10 series or whatever it may be, coming to any port. Then within the brackets, you are supposed to write what is the bracket MSG, that is message. So backdoor sub7 22 flag A plus, and content is this is the content. This is the packet structure content in the hexadecimal form, and the reference is the you may give some reference ID or any other thing, and the reference URL is this is the sub7 attack that you can identify, and you can fix it from this particular website like that. And SID is the simple rule ID. You can mention a rule ID, whatever your rule ID you want. Here 103. Class type miscellaneous activity, and revision is 4. So you can also mention the revision as 1. If you might have done this particular rule for first time, you can mention the rule revision. So since you have written for the first time, it may be 1. And if you might have made any modification, you can mention the version of the revision 2, 3, 4 like that, based upon the number of modifications you do it. So the rule is looking very simple. First one is alert TCP. That is whenever the TCP packet is received from the external network, from the some so and so port to the internal network to any port, and within the bracket you can write whatever you want. So that is MSG is message, and flags is the flag that what you want to mention. Content is in the hexadecimal form. You can show it. You can also skip this content. Nothing will happen. But the MSG is important, which is to be displayed out. But for the additional help to the security engineers, you may place the URL and how to fix it and all this kind of information. So elements before parenthesis compromises the rule header. So this is what is called rule header up to here. Elements in the parenthesis are rule options. So here are the options. You may choose, you may write it or may not write it. That is up to you. But this is the rule header is compulsory to write. So within the bracket, you can simply write a message and you can close this bracket also. You don't need to write all these things. So this is what the Snort rule, very simple to write. Another Snort rule, for example, alert TCP is the same thing, but which is further explained. Here, instead of alert, what you can write? Instead of alert, we can also write log, parse, activate, dynamic. So these are the other options that you can write in place of alert. Whenever you place log, then it will be recorded and logged. And pass means simply it will pass through it. Activate means a particular message to be activated or this kind of thing. Dynamic checking, you can do it via dynamic. So TCP protocol, you can also use UDP protocol, you can also use ICMP, you can also use IP. External net means external network. You can mention what is the source addresses. You can also mention the wide range of IP addresses, wide range of network addresses for the external network. So like that, you can also mention the port number. Whatever the port number from which you are expecting the request for into the internal network can also be mentioned. Next one is direction. So if the arrow mark is in the forward direction, then the outside network to the inside network. If the arrow mark is in the reverse order, then from the internal network to the external network. If the arrow mark is like less than greater than symbol, then what is the meaning of this is both direction. Okay, that is in both of the direction it is allowed. Next one is home network. You can mention the home network. Then any is nothing but any destination port which is on the host network. And what about the option body? So far we have seen the rule header. Option header is like this. MSG is message to be appeared in the logs. and flag A plus, which means the TCP flags many options like SA plus, not or SF star. This kind of flags are available. So each and every flag is having its own description. Where you can find this description is you can find the description in the Snort documentation. Okay, I will show you the Snort documentation. You can also download from the Snort website. So the Snort documentation consisting of this flag information for a particular protocol, what type of flags can be used and can be monitored. And next one is content. The content would what we have written in the binary form or hexadecimal form. So it's a binary data to check in packet. Content without pipe. So there is no pipe. If the pipe symbol was placed, or content without pipe, characters do simple content matches, and that means it will only check for the sequence of that binary data to be is present in the packet or not. The reference where to go to look for background on this rule. The reference you can mention. That is an additional thing that you can mention. And SID is the rule identifier. That is what is the rule number or rule identifier. If you want to uniquely identify that rule, what is the some number will be there. From the in the latest Snort intrusion detection systems, you have to use the SID greater than 1 lakh. Okay, so 1 lakh above number should be used for the SID like that. Class type, miscellaneous activity. Rule type, many others will be there. That is what type of rule it is. It is a miscellaneous activity or any other activity. You can also see the documentation and can come to know any other thing. Other options which can be used with the class type. Revision port, that is rule revision number. Other options will be like offset. If you want to monitor offset, you can go for offset. Depth, no case. These are the other options available. So here what I have presented is most frequently used options. And here are the Snort rules that will be available in the rules folder of the Snort installation. Backtraffic.rules, finger.rules, smtp.rules, DOS, denial of service.rules. So some default rules will be mentioned in this. So like SQL.rules, netbios.rules. Okay. So whatever the rules you want to label in the configuration, you can write a rule file for that. You are supposed to place in the rule folder, and you are supposed to give that rule file in the Snort configuration. Then any traffic which is coming into the network will be compared with these rules, and immediately if any alert is there, it will be showing onto the screen that some alert. So this is the way the Snort will function, and this Snort rules, default rules can be identified and can be downloaded from the Snort website. And you may also frame your own rule. For example, you want to check for the HTTP rule. You may write a HTTP rules, and in which you may mention the HTTP related rules. So like that, whenever you write this HTTP related rules and save that file in the rules folder, and that particular rules file has to be given in the configuration script. The rules which actually caught intrusions, like this alert TCP external net any SQL servers 1433. So the message is MS SQL XMP command shell program execution is initiated in that packet. And HTTP servers 80 and alert TCP external net any home net 21, then FTP access is going to trying to make by the traffic. So this is the way you can write the simple traffic rules, simple IDS rules in the Snort, and you can save it as the rule file, and you may write it in the configuration script of the Snort, so that from the next time onwards, whatever the traffic will come, immediately it will identify and will give you the information like the whatever the attack you are targeting for that with that particular rule. So the Snort architecture will be like this: packet string. This is a network interface. It will sniff it. Then packet decoder. In the packet decoder, it will check for the preamble, then the starting bits, then the content, headers, checksum, CRC, whatever it may be, which is available in the packet will be verified. Then it will go to the preprocessor engine. The preprocessor engine will preprocess the packet. That means it will convert into the binary form or hexadecimal form, whatever the form that you are requested for. Then detection engine. In the detection engine, whatever the rules you have written here will be checked. And if you find any attack or some other thing based upon the options that you write within the brackets like this, so that will be recorded into the file or some log, which is in the output stage. Then in the output stage, finally, if you give you the alerts or log record logs, so the data flow will be like this. So this is the way the Snort will function. It's a very simple program and will function very efficiently, even though in 100 Mbps or more data is processing or data is captured. So the rule header will be like this. This is the rule header and rule options. So you can write any options like this within the bracket. Okay. So rule header, rule option, rule header, rule option, like that. So the detection engine will be like this: rule node and rule header. Once the rule header is matched, then immediately it will go for the option node, and it will check for the which option to be verified and which option to be presented based upon the rule header that you have mentioned. So rule node and option node, like that, you can the Snort will check in a sequential way that is a rule node, and if first rule is not matched, then second rule, then not matched, third rule, fourth rule, like that. So that is the reason you have to mention the most frequently checked rules at the beginning of the Snort, and any other rule other than this can be passed easily. So for that also you may write a rule. Not if not all the above rules, then you can simply pass that particular traffic like that. So like that, you have to provide the which rule to be allowed and what is the traffic if it is not matched with the above rules. So these two things has to be mentioned in the Snort configuration script. Then it will be easy for the Snort to accurately detect the rule or the attack whenever it comes into the system. So to conclude, Snort is a very powerful tool, but maximizing its usefulness required a trained operator. It is nothing but you must have a complete knowledge of the packet structure, packet form, and various options available in the Snort, so that it is then only you can do it. So if you are a computer science engineer and you know the computer networks, basic concepts and all, it won't take not much more than 12 months to master this intrusion detection system from scratch. Okay, and if you want to become expert, you need to wait for practice continuously for around 3 years so that you will become expert in this. Snort is considered as a superior network intrusion detection system when compared to the most commercial systems. Now some other commercial systems are there, they are competing with it, but still Snort is popularly used because of the features of the very low size, very small size, faster action, and faster detection capabilities. So because of this small size, it can also be used on the electronic components and the microcontroller based platforms such as the Arduino or the Raspberry Pi and this kind of things. There also you can use this Snort, and you, because as you know the Raspberry Pi or this kind of systems are equipped with the LAN card also, and which can process gigabytes of data over that small device. So whenever you have this LAN cable connectivity or the LAN card connectivity and network interface connectivity, including Wi-Fi and this wired network connectivities, so you can also install this Snort on the Linux platform that will run in the Raspberry Pi, and you can place this small device at the entry level of the network, so that immediately the whatever the traffic which is coming into the network can be sniffed and detected by the Snort intrusion detection system based upon the rules that you write, and immediately it will be giving alert to the server. So for that, you no need to establish a big server, and you need to no need to place Snort in that. Only thing is just a small Raspberry Pi, which will cost less than 6,000 rupees, okay, 5,000 rupees. That you can purchase it and you can install Snort, and you can place at the network perimeter level after the firewall. Then you can easily detect the attacks. So that is the reason Snort is still booming today and is popularly used nowadays. So it will work efficiently on the servers and also the small scale devices such as Raspberry Pi or Arduino microcontrollers. Snort installation will also be can also be done on Linux operating system. Basically, because of the lightweightness of the Snort, you can also install on the small scale devices like the Raspberry Pi and Arduino microcontroller. So this kind of small scale microcontroller devices on which the Linux operating system is installed and which is running on that. There also you can install this Snort. The main thing that can be helpful in the IoT is IoT devices usually connect with each other via internet, and they will communicate over the internet for exchanging of the data. Usually, these IoT devices may be having the sensing devices at its end. This may be sensed either it may be environmental sensing or maybe sensing of a component or maybe any other thing. So whenever this components was sensed and the report is sent out, and whenever it is collecting at the destination end, either it may be at the base station or it may be at the server level, or any traffic which is going out of the IoT network. So if you want to monitor for any intrusions in that, because nowadays everything is becoming smart devices. Like even if you purchase a fridge, also you are getting a smart technology there. Directly, just make a phone call and press a key over that smart device, and automatically smart diagnosis will take place, and you will get the online help. Whenever you are making online help, there you are supposed to press a button, so automatically a number will be displayed. If you enter that number, immediately that call center people will guide you via that device itself. See, like that, some smart device, smart diagnosis, and you are getting the what you call devices like ACs and all air conditioners. You can send an SMS before entering into your home, and this air conditioner will automatically on and will cool to a certain temperature and will off automatically. So this kind of things are all smart based. So all these are kind of Internet of Thing technologies where this sending of SMS, receiving, or smart metering, smart what you call the electrical equipments, all these will work with the internet connectivity. That means there should be any router should be placed there, or maybe some switches or some internet connection will be there. So based upon that, these devices will work. Without this router and internet connectivity, these things will not work. And you can also integrate these smart devices with the what you call Alexa or OK Google. These kind of voice to instruction conversion related applications can also be used for just without having physical input, without giving physical input, just by voice inputs. These smart devices may work. So that means there exists several places. There is a wide way of wide variety of chances that attacker can come into the network. In such a cases, how you can monitor this? That is with the help of the intrusion detection systems. Anyhow, you will provide an endpoint security. Even though you provide an endpoint security, sometimes some security threats may be evading the endpoint securities, or may enter into the network perimeter, may be stopped at the endpoint security, but may be entered into the network perimeter. So whenever it is entered into the network perimeter, how you can identify such things? So without the intrusion detection prevention systems, it is not possible for us to detect. Especially these are useful to these are useful when for the early detection. Without entering into the network at the level of the perimeter itself, we can detect such things. So for that, is it okay for us to place a separate server and this equipment and all? No, actually, this IoT devices and all are small components, very small in size, and also very lightweight. And you will see the RAM required for that, and this kind of things are also very small. So instead of placing a separate system over there and connecting to the network, then monitoring and all, so this is not a feasible solution. Hence, we need to place a small component like Raspberry Pi devices, etc. So it is of a small, like it is less than your mobile phone size. So you can directly place there and you can connect to the network. And obviously, these devices will use the Linux as the inbuilt operating system, and in which you can also install Python programming and many other programming languages to interact. So anyhow, when you have the facility of installing the things by connecting to the main system, so why can't you install Intrusion IDPS like Snort, which is a very efficient, which can capture the already known attacks with the help of the rules that you have written with high accuracy, even when hundreds of Mbps data is coming into the network. Anyhow, if you look at in IoT technologies, you won't find that much gigabits of gigabits of traffic. Always you will find megabits of traffic. So Snort is a powerful and efficient IDPS that you can incorporate in the IoT devices, especially to monitor the intrusions in the network traffic. I hope you got this. Why we have chosen this Snort IDPS for this course. So Snort is a flexible, very flexible signature-based intrusion detection system, and also a network-based network intrusion detection system that can be easily incorporated and installed on the Windows operating systems. May not be Windows 10, maybe any old operating system also it will work. Okay, but it requires very small memory to run, and but it will work efficiently. And its variants can also be installed on Linux operating systems like Fedora, CentOS, and any other things like, for example, in case of Raspberry Pi. And these are the various other devices where you can install this Smart.